PPT.
Can you see my screen, the PPT?
Yep. Yep. So you can download it. On the top screen you see print button, then the download button. You can download the PPT. Now download here. So this PPT we're gonna use during our session.
Okay.
So it is having roughly around 21 meg and somewhere around 340 slides.
Okay.
So this will be our base slides to go through for all the sessions.
Okay.
Other than this, we will also have the lab sessions. So when required, I will share the lab sessions and PDFs with you.
Okay.
Okay.
Okay. Were you able to see the PPT?
Yeah, I am able to see that. So once it is downloaded, open the PPT directly. I guess it is downloaded. You can check your download folder. You can open the PPT from there.
Okay.
Cancel it again. Yeah.
Can you see now?
Yeah.
Okay.
So did you open the PPT?
Yeah. I opened
Okay.
the PPT. This is the open PPT.
Yeah. Go to the screen, slide number 2. Go ahead. We will try to understand the concept of cloud computing. We will understand what are the Amazon major markets for AWS. We'll also understand like what is basically AWS, what is the main AWS talks about, okay? And then we basically design our own AWS powered system. When I say AWS powered system, it means end-to-end. It's not only the web server or the app server. It's like the complete architecture, how it basically works. So we should be able to understand, okay, so how the RDS, how the application, how the web server, all these things works.
Okay.
And we also will be able to understand what is the next and where we can learn more in detail.
Okay.
Yeah, next.
This is
our so this is our course schedule. So basically we have introduction, we have cloud computing and AWS, that is our theory. So after that we will get into the Amazon EC2, that is nothing but a compute. So it talks about the complete compute story. And then we will understand into the EBS, that is nothing but a storage. So it's like a more of a disk, a hard disk kind of thing. So it's called as basically elastic block storage. So it is a block storage basically. Then next is S3 and CloudFront. That is basically a object storage. So that is more over like a Google Drive or something like Dropbox. Whereas the EBS is something like an external hard disk that you attach to your laptop. Then Amazon SDB and RDS. SDB is simple database, RDS relational database. So that is both are databases, DB. Then SQS, that is nothing but a queue services. So that will make you understand how a multi-tier architecture can work on cloud computing, and how basically we design a scalable solution by using queue. Because the solutions that we create in data centers or in our normal scenario, they basically are more over request and response object based. Whereas when we talk about cloud, we cannot create architecture where request and response object work together. There has to have a different kind of framework, and those framework basically works over queue. So that's why we will understand, okay, why we need queue and how the architecture will change. Once we understand the application architecture and queue, then we have to get into the core networking. This is more over related to networking, security, and all that other stuff. Once you've done this, then you have project, you can do it by your own. So,
okay.
Next.
Cloud computing.
So so basically, so in this cloud computing, you can see there are like everybody talks about it, like Gartner, IDC, CIO, and they have their own terms. They basically talks about how the cloud is overall will be influential, how it will be influential as the e-commerce business. Like how today, without website, none of the company can even exist,
Okay.
because there was a time when company do exist and they don't have websites. There's no e-commerce before 2000. So people
Yeah.
do business. People have everything. Even everything works properly, but there was no website. But today, if we understand this way, if a company doesn't have a website, it means the company doesn't exist. That's all. So it
Okay.
almost, if the company doesn't have a website, company doesn't have a wiki page, we cannot, we will think in that way, even though how big is the organization, we'll think it may be a fake, that's all.
Mm-hmm.
So because of, we basically now understand that the legitimate of a web of a company is just because we can see some data on internet. If there is no
Mm-hmm.
data on internet, it means it's not even legitimate. So now think
Okay.
about what the people think in the manner where e-commerce is just a business. Now e-commerce begun as giving a legitimateness of a company or a business. So yeah, it's this is how the turnaround. So same way people are talking about the cloud computing. So when
Mm.
people say just applications that work on a hardware or servers, now people are saying it's way beyond. It's the cloud computing is the future. And that's what the truth is. Overall, it's this PPT was maybe created in 2005 and 6. Now we are sitting in 2007, 15, 16 and 17. So in that
Mm.
scenario, yeah, it's become true. None of the business can grow. None of the business can even stand where they are if there was no cloud computing. So, okay. Now, actually, let us understand how the cloud computing is all about. So cloud computing is a massively scaled offsite IT resources assembled virtually, accessed over the internet, used on demand or real time, on near real time, and pay as you go or maybe subscription basis. So first of all, we have to understand what exactly he's talking about. So cloud computing is a massively or a very, very huge scale of data centers. So in other words, cloud computing is it's basically a very huge data center. That's something that has terabytes of RAM, tera or petabytes of your storage, and few peta gigahertz of compute. So definitely a millions of compute, millions of billions of storage, and millions of RAM I'm having. That's what my understanding. Then
Okay.
these all are IT resources. So what's for sure this is created for IT, no problem. But this IT resources are virtually assembled. So means nobody will have direct physical access to any of the component. All the component will be hypervised and the virtual component will be created. And people will be able to access the virtual component of it. It will access over the internet. So whatever the virtual component you create, people will be able to access over the internet in the real time or near real time. Whatever they need, they will access it, they will need it, they will use it. And pay as you go. So depend upon they want to pay subscription or they want to pay per hour basis. So depend upon their need, they will pay. And all the workloads, means all the physical workload will be shared among multiple customers. This is actually cloud computing. So right now, if you can think an example of a cloud computing, everything is like that, like Facebook. So Facebook is running on a physical servers. Nobody has the access to the Facebook servers directly. Everybody uses the application. You use in the real time or maybe near real time. They're massive servers. You access those servers over the internet. You post your photos, you post your application. Facebook is not only used for your just putting your photos. Facebook also used by media companies to publish their data. It also used by many websites to publish videos or publish marketing way to do things. So Facebook is also a place where media marketing is going on, right? So think about those companies who basically use this platform as a media marketing. So they post the data. They use this service, and that's how this is available to the people. If you don't want to think as a Facebook, think about of Salesforce.com. Salesforce is some kind of website that give every kind of ERP model or the business model to the customers. They access over the internet. Definitely Salesforce or the companies will have a very huge databases. So it will run on the servers of Amazon Compute. And then finally, people will be able to access over the internet. When somebody is accessing over the internet, they have to pay if they want to use those applications. So they will pay to Salesforce or they'll pay to Amazon per hour basis or monthly subscription. But who all are using? Do I know? No. Anybody can use it. Everybody can use it. You can. So Gmail is, think about a mailing engine. How many people globally using Gmail? Almost everyone. So is the Gmail is shared? Yeah, it is shared among everyone, right? You all have a faith and put your mails on Gmail. That's all. So Gmail server is a huge service. Though he is not charging from you, he is giving you free service. But there is, think about a time where if it is charging, you will pay as per your data or as per your usage, and that's what people are doing. Gmail is available to the users as a freely, but Gmail for work is available. People use Gmail as a work, right? So there's something called as Google for work. So people use Gmail for their work, and that's how this is available for people. Clear? Go back to the previous slide.
It looks like what you told is in here, so I moved on to the next one.
No, not needed. I'll tell you. Go. So basically, so as the definition, whatever it says, the definition itself means, like first, it's a very massive server. It's in real time. You use it. You go as a pay-as-you-go model, right? And on the other hand, it is accessed over the internet. Now, these all example, whatever I'd say, computing. And that's why we say every business is right now is a cloud. Hello, can you hear me?
Yeah.
Okay, so that's why I said every business is a cloud. So every big software, whatever is running in the market, they are building some kind of cloud. Okay, now let's go back to what Amazon is building. Amazon is also building a kind of cloud. And that cloud, he is not giving any application. He is not giving any software, but what he is giving, he is moreover giving a services. And that is moreover infra-related services like compute power, databases, networking, security, storage. So that is a basic component basically we need as infra. We need servers, we need storage, we need object storage, we need databases. So all these services given by the Amazon. So what Amazon done? Basically there are physical resources. So those huge physical resources like compute power or the storage server, he hypervised by using Zen hypervisor. So by using Zen hypervisor, when he hypervised all the physical servers and storage, he created virtual servers and virtual storage. By using virtual server and virtual storage, we can definitely do everything because I have the complete power now. So then I can give object store like S3. We can give SQS like queue mechanism. We can give DB database. We can give EC2 like Elastic Cloud Compute. That's basically the virtual machine itself. And the EBS, that's a hard disk. So if I have a virtual machine and a hard disk, think about what you have is a laptop, right? You have a virtual machine, a laptop, and you have a hard disk like an external hard disk. What else you need? You can do everything or not. So that is what people are getting from it. Other than that, there are more 87 services that what Amazon can give. So across the globe, whatever a company need as an infra-wise, Amazon can provide. Virtual VPN, networking, target-based VPN, routing, switching, everything. Whatever people want, Amazon can provide. And for that, Amazon will charge. Now how people can access these services? They can access over internet. So you can access over computer, laptops, mobile, servers, desktop, anywhere. So these are the components that user like you and me uses to access the services. Those are named below, like S3, SQS, DB, EC2. So those are the services, and that all services are created by either compute and storage, virtualized, and that all basically runs on the physical hardware on real time in Amazon. So that is all about Amazon. Next. So this is a real data center. That is how basically look like. So if you ever been into any physical data center, you will see that on the right hand side you can see those are the storage boxes, and on the left hand side if you see carefully, those are like a switches. You can see there are like end of the row switches or the middle of the row switches. So those are like half rack switches. On the full rack, if you see top to bottom, that is 48 RU, that is like a servers. So each and every server is individual blades. So those are basically nothing but a blades. So those are blade boxes. Right? So those are blade servers. Whereas on the right hand side, you can see the storage boxes. Those are like hard disks.
You want me to scroll down?
No. Now basically, so this is all about the database, data centers, Amazon, and how things basically we are going to look when we think about the real-time data center like Amazon or Google or Facebook. So that is what we understand as these boxes or these servers. Now we want to understand, okay, how we basically come to there. We see these boxes, we see these kind of servers, we see Amazon, we see cloud computing. So we have to understand the history of the computing. So let us understand how the history came till here. Okay. So, okay, understand one more thing. What we are talking is all theory. Okay, and this is gonna be there for 2 days at least.
Okay.
Okay, and then you will start with the practicals and everything.
Okay.
Okay, so when we talk about the evaluation, so the first thing is start with the web, and you say web 1.0. It is in 1990s when it's a completely one-way information. So if you talk about one-way information, think about like you go online, you see some data, you download the information, you come back. Like some websites are like just informatory. It gives you information. You just read the information, note the information, and come back. So that's how supposed to be the website in 1990s. But things change dramatically. Things change depend upon how basically people are start using. Go ahead, next slide. So in 2000 or early 2000, the things has changed, and that time basically it is web 2.0. 2.0 is like a bidirectional. When you start sending emails, a user can interact with servers. It's not only server giving information, it's the user interacting with the server. Secondly, user can give data on a server. So you can see the websites like Hotmail, Gmail, not only that, then Facebook, Orkut, all these things started up. If right now you talk about whatever you see on the internet, all the data created by users. Okay, just think about how many photographs you ever see on Google, how many things you ever see on a Google, how many videos you see on a Google. It's everything created by the users. Whatever photograph you see on Instagram, Instagram is the biggest photo library ever. It's all created by user. Whatever blogging site, whatever information, whatever people, discussions, everything, whatever you see on the globe, it's all created by us. It's created by the user now. So the biggest videos, whatever you see, it's created by users and uploaded on YouTube. The website is not giving anything. YouTube is not uploading any data. Right? Facebook is not uploading any data. It's the user who is uploading the data. So the massive data, whatever we see on the internet, it's all belongs to us. We created it. So that's the thing that has changed now. So from the 1.0, when we move to 2.0, things dramatically change. So in 2.0, we realize that user has a capacity to do everything, and they will do everything. Not the website will not drive the user, but the user will drive the website. And that's why we can see all the e-commerce based business, all the internet based business drive by the users, not by the companies. So what user like, the user will move in. That's all. So when people know that Facebook come in, or could loses its charm, yeah, it has to go. When we know that, okay, some softwares came in, people start moving into that softwares. That's how the thing will work. Now, after that, Web 3.0 coming. Next. So Web 3.0 is something called as cyberspace. When I talk about cyberspace, here, actually website is watching you. They know you what you are. They know who you are. They know exactly what you belongs to. Okay? So in 2010, things change completely. Now, take example. You search a flight from US to India. Okay? And you search for a while and then you thought of it's costly, leave it. Now you go anywhere. You go like on Facebook, you go Gmail, you go anywhere. And you see that there is an ad. And that ad exactly the same flights that you're searching for. You search for a while, like you search for some shoes, you search for some dress, and now after a while you will realize that every ad is exactly the same what you're searching for. The same thing, the same shoes, the same shirts, or the same clothes what you're searching for, the same flights. So whatever you search for, whatever is there in the brain, you basically can see from some other websites, right? So people exactly know what you want at this stage. Not only that, now even when you come out of your office to your home, before you will just do anything, even if by mistake look into your phone, you will realize there is a Google now. And if you by mistake click on it, he will tell you, okay, another 45 minutes you will reach home. He knows that this is the time you're about to leave office. And he knows that it will take around 45 minutes to reach a particular space. Even though, take example, you are a best driver in a globe, and you challenge a Google and say, no, I already drive every day from this lane, and it never takes that time. But Google says 45 minutes. You beat the Google. You cannot. Because if you ever drive, you really know that if Google says 45 minutes, it is going to be 45 minutes. Because they have exactly the right precision data at that point of time. So that's what Google is. If Google says on this circle you will take 5 minutes, it will gonna take 5 minutes. If Google says you in another 45 minutes you will be in this location, yeah, you will be sharp on that location. So that's how they knows now. So exactly Google knows where is your office, Google knows where is your home, Google knows what time to what time you stay where, at what time you will be on this location, and where you will be in this point of time. Not only that, think about if you ever search something called as history.google.com. Okay, if you ever type this link on your browser, you will realize that whatever you search till now, whatever you search, from the day you ever started computer, till date, whatever you search, it's there. Time-wise, date-wise, exactly seconds-wise. So at morning 9 o'clock you search for a company, 9:15 you look for the address, 9:20 you're searching on a map, 9:25 you're searching for the exactly some nearby coffee shops, 9:50 you search for some name, 9:7 exactly the date-wise, time-wise, everything you can see. That's what the Google knows about you. So this is what the connected world. Now we are not living in our cyberspace. We have moved ahead of that. And now we are saying something called as ultra, or in fact it's called as ultra zone. So when I say ultra zone, it's basically everything is connected. We basically want a life like where we don't want to drive our car. When I want to go office, I don't want to drive my own car. And we don't even want to hire a driver. We want a Google car should be standing and it should take us to the place. You know, most of the MRTs, most of the trains doesn't have drivers, right? Most of the metros will not have ever any drivers. They drive by their own. So the biggest trains, whatever you see, it's driverless. So they all controlled by computers. Most of the buses, whatever is running right now on a specific routes in Singapore, they are driverless. And you know, in Singapore, it's a best transport in the globe. People don't use their private transport at all here. They all go for, public transport. And now they're coming with the taxis, which is not having any drivers. So at this stage, you can think about people are basically moving into the ultra zone, and that all is happening just because of one simple reason, that because of the cloud. If you don't have the hybrid technology, you don't have the cloud, we cannot move into this space where everything is connected from your cars, homes, connected internet, everything. And that's why we have to move into technology called as IPv6. So IPv6 is called as network cloud. Server level clouds are Amazon or Azure or Google Cloud. So if you heard about Azure, it's a Microsoft biggest cloud. If you heard Amazon, it's a Amazon cloud. And if you heard about cloud.google.com, it's a Google cloud. Okay. So that's all right now we see as a real time. Other than that, this all is happening due to one topic, that's called virtualization. Go next. Okay, so virtualization says one simple thing. Virtualization says that you can run multiple virtual machines over the same hardware. So you just have one base hardware, and over this base hardware you can run multiple virtual machines. So every virtual machine will have their own piece of compute, RAM and storage. So that's what all about the virtualization technology. So effectively it's basically a small unit of the main huge servers. Okay, now if people talk virtualization as a new, no. Virtualization is a pretty old technology. Okay. So when I say virtualization is a pretty old technology, even in 1960s, virtualization do exist. That was a time when people have the mainframe, and that mainframe people basically give a part of the mainframe to the users who need it. So think about a company like IBM or a very big company, that time HP, has a servers, and they rented these big mainframes to the different companies. The company is sitting on the T3 link or T1 link with the terminal servers, and they can access the mainframe. That's what basically happened at that point of time. And how they share it? They share it by using some kind of that, the very old, like metahertz, gigahertz, and those things. So that's how they basically, now it is called as gigahertz, and this, that time is called as metaflops. So metaflops or petaflops or teraflops is the basically number of flip-flops basically that can handle that many requests that point of time. So that came in. But after 1980s or 90s, personal computer came in. Because of the personal computing, the hello, am I audible?
Yes, you are audible.
Okay. So because of the personal computing, the main line has been lost. And what exactly the change happened? The change happened this way, that people started using their own servers, own computers, and company, because of the computer become cheaper, everybody can start buying computers. But soon, it's not the late, when they realize that the computer capacities keep on increasing. Now even your phone has octa-core. Whereas at the time, if you remember, you have like dual core or single core processor with 4 GB RAM or something. Now even a phone is coming with 6 gig RAM with octa-core processor and 128 or 256 GB of hard disks. So when you can see that this small device can be this strong, now a server can really come up with 6 terabyte of RAM, almost 28 processors with quad core, something around 108 processors on the same board, with terabytes of RAM, roughly 6 terabyte, and something around roughly 30 to 40 terabytes of storage on a single board. So think about a single motherboard can have this. That's called blade server. So that's how the computing changed altogether. Go to the next slide. So that's how the company, almost the virtualization, and because of this all, the computing completely changed, and that change basically makes moved into virtualization. So people in the main frame leaving its business at 1960s and coming back again in 2005, 2006, they start again using virtualization. And now virtualization is a core. Without virtualization, we cannot do anything. So virtualization in simple word, it's basically a technology that allows running multiple virtual servers over the same physical box. Go next.
Shall I go to next?
Go ahead next. Yeah, so virtualization basically categorized in two things. One is called as process virtualization, other is called as system virtualization. Carry on. So process virtualization is a pretty old topic that we all are aware about it, like Java, JVM, .NET, Rasa, Pin. These are like basically what they do, some kind of process virtualization. Why? Because you can write your own bytecodes and they can run on multiple operating systems. They don't care where you have wrote this program and where you are running it. So that is the beauty of this process virtualization. But what we are talking, it's called a system virtualization. Go next. So we are more interested into system virtualization. Okay, system virtualization is different. System virtualization basically is a gift given by VMware, Xen or KVM. So this basically comes when on a single hardware I can run multiple virtual machines. And if I'm running multiple virtual machines, that each virtual machine can have is independent application and database layer. So think about one server is running independent with having own application layer and database layer. We can run multiple such virtual machines on a same hardware. So on one hardware I can run up to 5,000 such applications. So that's overall the beauty given by the virtualization. Clear? So basically it all happened due to the VMM, that's called virtual machine monitoring, or a hypervisor, basically another word. So hypervisor is a software that allow to run multiple virtual machine to allow multi-threading architecture so that I can run multiple small virtual machines over the same hardware. Clear? So this is what it's given over here. There are two types of hypervisor now. So when I talk about a VMM, it is nothing but a hypervisor. So there are basically two types of hypervisor. One is called as bare metal. In this, there is no operating system installed. So you buy the hardware out of the box and you directly install the hypervisor on top of it. The name where we can see is ESXi, KVM or OpenStack. They are just directly installed on the bare metal, and over which you can run up to 5,000 servers. Whereas hosted is something like a Hyper-V or like a VMware workstation or some kind of virtual box or a kind of sandbox architecture, where you have an operating system over which you will install some kind of software that is called a virtual box or sandbox platform, over which you will run your virtual machines. Clear? So you have hardware over which operating system, over which you run your own hypervisor that will give you sandbox architecture, and then you will create the virtual machine on top of it. So on Amazon we use Xen. Xen basically uses a bare metal hypervisor. Next. So the time is almost 11.
Amazon, AWS.
Yep. So you can subscribe for the Amazon AWS, and it is free for everyone. Anybody can subscribe for it. When you subscribe for the first time, it gives you a free tier of 750 hours. So you can utilize this 750 hours for almost a year subscription. So it will give you a 1 year subscription, and in that you can utilize this 750 hours. So whatever we're gonna train, whatever we're gonna learn, it is gonna be on the same free environment. You have to just enroll for this. You have to just go on awsamazon.com. I'll tell you how. You have to basically create an own account over there. It will do ask the credit card. The credit card information it will ask if you do it after a year. Okay. After this lessons or the chapters, you can just delete your account or remove your account. So it will never gonna charge you anything on your credit card. Though when you set up your account, it will charge you $1 on it. Clear?
Yeah.
Okay. Carry on. Now, why basically people go for cloud computing? So we heard about what is overall the cloud, what things are going up, how the technology is changing. Now, when we say the cloud computing, the first thing, why now everyone is jumping into the cloud? The first thing is that. So first thing is cost effective. Because when I'm using a cloud like Amazon, I'm not buying any hardware, right? The first thing when you ever want to start a business, the first thing will come. Okay, I want to host a website. I want to make some IT infrastructure. I have to run servers or I have to do something. So every business nowadays have to look for some kind of infrastructure management. And that is costing because you have to buy servers and that is not cheap. IT infrastructure and IT gadgets are not so cheap in the market. So you can understand sometimes millions of your dollars just invest in the IT infrastructure. Rather than if you go for Amazon, you don't have to put any hardware cost. Those all IT infrastructure will be free. What they will charge you the usage. Next, virtual or speak to value. So if I buy a physical hardware and if I ask some guy to configure it, it will take some time, weeks or days to do the job. But whereas on Amazon, it is everything is virtual. On the click, things will happen. I will right click, I'll configure things, I'll make things up and running. It will just happen in a while. And that's why it is much faster. Storage elasticity. If I buy servers, at the end of the day, if I have to increase anything, I have to buy more hardware. I have to buy more resources. Whereas on Amazon, right click, edit settings, and I can increase the storage capacity from 1 GB to 1 terabyte at any point of time. So it is completely scalable. Subscription style. If I buy something, I have to pay first. Whereas here, I can use it and I pay as I want per hour basis, or I can take a subscription per month basis, or I can take annually. I can pay annually once. So however I want, I can pay. Clear? Less stress because I'm not owning any hardware. I'm not owning any kind of facility, so I don't care about any power outage, any kind of cooling, patching, latency, QoS, or cooling. Everything will be managed by the Amazon themselves. The last is redundancy. So it's very simple. It's the architecture they define in such a way that everything is designed for fail. In that situation, if anything got fail, it makes sure that nothing you will lose. That's how the design is overall. It's the same repeated slide. Carry on. Okay, so this is basically the forecast and the nightmare for the people. So you can see the straight line, that is basically a forecast workload. So that's how the business runs. So basically, if any company will start, they have certain kind of forecast load. So they say on the year one it will be this, on the year two is this much, year three this much, and that's how they try to buy the hardware depend upon the year-on-year requirement. But the problem starts here when the year-on-year prediction changes with whatever they have to buy, because every year when you say, okay, I want to buy $10,000 every year, $10,000 hardware, okay, but that you have planned with a scale, with a architect who suggested, okay, year one it will be this much or year five it will be this much. There's a straight line, but actual requirement is never can be like that. It can be possible that first year you don't even need any hardware. It's never been utilized. So it is just a waste of money. So rather than doing that way, if you go on Amazon, if you're not using any of the servers, you will not get charged. You will only get charged whenever you are using it. Okay, it means if you are using it, it means that you are earning money. Okay. Okay. If I set up something on
Hello?
yeah, can you hear me?
Yes, I can hear you. Hello?
Yeah. So if I set up
Yes.
something on Amazon, It will not charge me anything until I power on, until I use it. So in other words, it is as simple as that. If I'm not utilizing, I'm not charging. I'm not getting charged. And if I am utilized, think about, you put some servers on Amazon, okay, some kind of application, and first month nobody uses it, not a single customer. You will not get charged. But on the second month, it is heavily utilized. Every customer use it. It will be charged, no doubt. Okay, but if it charged, you are happy because it means that your servers are utilized. It means you have customers, and if you have customers, it means you are getting money. Then what's wrong paying to Amazon? So that's how the business runs here. I get money first, then I pay Amazon. It's not I have to pay from the day one to him. So that's how things will change here. Next. So there are basically two kinds of deployment. One is for private and public. So in private, like, the deployment will happen specific to an organization. It can be done by the company itself. It can be done by the third party. But it will be wholly utilized by a particular organization. That's called private. Public, it can be utilized by anyone. It can be created by anyone. It can hosted anywhere. So in simple word, it is offsite, third party, and it will be used by the public. But there is something called as hybrid cloud. Hybrid cloud is a combination of private and public cloud. That's all. Community cloud. Community cloud is again a type of public cloud, but only accessible to certain group of users. Like Android cloud. Android cloud is a complete public cloud. Anybody can sign up. But you have to show some meaning. You have to show that, okay, I want to use that cloud. For that, you have to show that to Google, okay, I want to develop these applications. And for this application, I need a cloud. Google will give you, like how Amazon is giving you. But Google Cloud is not available for everyone. It's only available to the Android community. Clear? Next. So that's the same thing, private, hybrid, and public. So any combination is called as hybrid. Next. Now there are three ways of delivery. One is called as IaaS, PaaS, and SaaS. Infrastructure as a service basically gives you the core infra, like compute, storage, and network. Platform as a service. Over the infra, they give you a platform, means operating system, application, and database layer. That's called platform. Means you don't have to install anything. Everything is ready-made. You just start writing your code. It's good for development. The last is software as a service. Ready-made software you get. You don't have to install anything. You don't have to do anything. It's ready-made done. You just use it. Like LinkedIn. It's a ready-made. Job site like Naukri or Monster. Ready-made. Gmail. Mailing software. Ready-made. You just use it. You don't have to configure anything. You don't have to design anything. That's called software service. Carry on. Next. So in other words, in the infrastructure as a service, the company will take care of networking, storage, server hardware, virtualization, and the servers. What you have to take care, you have to install your own application, runtimes, your security, and your databases. Now, if you talk about the platform as service, everything will take care by the company itself. Only you have to take care about your applications because you are deploying the application. You are the one who is basically creating this application. Like Android cloud, you are developing some application, you are designing some application, you are giving something. So that where you have to take care. Rest everything will take care by the company themselves. Third is software service. Everything end to end taken care by the company. You just use it. You pay only for what you use. That's all. Okay. These are the major cloud infrastructure providers. The name is other than the Amazon. Amazon is top leader. Then we have Microsoft Azure, Google App Engine, IBM Blue Cloud, HP Helium. HP Helium has moved to enterprise from public cloud anymore now. Joint, Rackspace, and FlexiScale. This is a complete cloud ecosystem. So you can see all the type of companies, whoever being into any type of cloud like IaaS, PaaS or SaaS, they are here. Next.
Company.
Yep. Now we will stop it here. Okay. Uh, okay, one more thing. So I guess you joined today, what time? At your time, 6 or 6:30?
6:30.
6:30, right?
Yeah,
As we discussed, like 6 o'clock, right?
6:30.
So you cannot join at 6?
6 is too early.
Okay, no problem. So we'll start with 6:30. Okay.
Yeah.
So